they used to pray or they have cancelled it? So, your exam is here already. If you have not been working for a very long time, if you have not been reading, if you have been so unserious, let me put it that way, or you have not been allowing yourself to work, this is the time now to work. Something is... So, this is the time now to work, every one of you, if you have not been reading. You only have like a month, so to say. So maybe like 46 days to your exam. So you have like 46 days. So you should do everything in your power. Let me check this thing. Thank you. Please, I want to beg you all, and note one thing. Last year, JAMB, a lot of people passed. A lot of people passed last year, JAMB. It was the norm. And most times, when the previous year, people passed very well. The following year is always terrible. Alamoni, just listen to what I'm saying. But however terrible it may be, one thing that we have noticed, or that we all know in primates, is that year in, year out, the result of the following year is always better than the previous year. It has never happened before since we started primates. If this year, go and check, I think we just removed the board of the 2 years ago. Those of you that came early last year, you would have seen a small board. That was what we used to do results 2 years ago. Now, last year, we did not even know what to use to do board. And that's why we did a very long board that is at Songo. So, which means what we are expecting this year is that we should even have a board that there will be no space to contain it at all. That's the expectation this year. Convincingly, sincerely, I think I told them last year at some point, I told them that I have not seen their work. And it's not obvious that they were ready for the exam. I kept on saying that at some point, because I noticed in the class that these people, and sometimes I can predict people's scores. Don't come and meet me, I'm not a soothsayer. I'm just trying to tell you that sometimes if I spend time with you as my students, with time, I will tell you what you are likely to score in your exam. But this period now, we've had a lot of teachers, we divided the topics, we all took our parts, which means that apparently the syllabus should have been somewhat covered to some extent. Last year, we started around September 1st. And we covered the syllabus till December. Then January, when we resumed, we started the syllabus all over again. And that will be, we will end everything by this March. So April will only be for solving questions. So the point I'm trying to make is that no matter what now, for me, if they say I should speak, I'm scared for the majority of you in this place. And this is not just like I'm trying to say it so that you people will feel, I will say it if you are ready. I will say it. But I'm obviously scared for majority of you in this place. You are not ready for JAMB. You are not ready at all. And as much as possible, I want to still beg you. You have 40-something days. Someone can cover syllabus in 40-something days. And we still do well. And a lot of you don't make positive use of what you have, your tools. There's no time I'm coming around and going. Most of you that have phones with you, you are either playing soccer or you are playing Call of Duty. So you are not making positive use of it at all. At all. And in this generation, if you decided not to still have brain, with the way things are going in the country, with the way the world is growing, with the growth, with AI tools, with everything every day, you don't need to be a computer geek to learn many things these days. With the way things are growing and you are not following the growth, you are not following the trend, then it might be a problem for you. I'll be teaching physics this morning, but before I start the class, I implore all of you to use your 46 days left or count 30 days left to do everything on your part. Even if many of you, I'm sure that since you started preparation, you have not even seen syllabus to your face. You can print syllabus, you can download syllabus. Take your syllabus. You don't even have any textbook. Let's say you don't have textbook. Take your syllabus now. Use your phone to scan it. Divide it into, I don't know the number of topics that you have in the syllabus, but for chemistry it's up to 70 something. When I used to count. During my own JAMB, if you needed to, I should have, sometimes some things we use, we should put it in museum so that people can see when we are talking about it. You will not think it's a lie. My syllabus was painted, it was like syllabus was my notes. My syllabus was painted, and my teachers then used to ask me that, do you want to become a teacher, this and that? Because if I'm going to class, they give you a question, you know it. But there are some topics left that probably you do not know so well. Then snap, there's what it is called count scanner. You can have count scanner on your phone. All of you should know that. When you have count scanner on your phone, you use it to snap. Then when you snap, it will make it clean. Then you upload it to any of your AI tools. You can pick it simple by simple, because if you brush AI with everything, it will start saying rubbish at some point. But you can just break, maybe the note is much, just break like a section first, and you give it prompts. You upload it, is either you first ask it, you don't even need to say you should type it out. You just give it prompts. Some of you are even rude when you are talking to AI. You can't even use please. We know it's machine, it does not have feelings. But today too, they are saying I'm sorry these days. So when you scan it and you upload that part, you say, explain in full details without missing any part. All I need to know, and the best way to understand and remember these things, tell your AI tool to explain it. You can have different ones, because this thing might know, one might tell you to go and subscribe later. But you can have different ones. You can have different email. When one say go and subscribe, because many of you might not be able to pay for all these things per month. At least, a lot of you still know your ChatGPT. ChatGPT can help you. You can use, I think there's Cloud too, Abby. You can use Cloud. You can use, which one is common on your Google? Gemini, Abby. You can use Gemini. You can use DeepSeek. All of these are tools you can use. This, then, I think there's Grok too. This one now, immediately you are through with that topic, and you can even say it should link you to YouTube videos that will explain the topic better, and it will give you a list of videos. And you will open the YouTube video, you quickly watch it, you read the story that this one would have told you. Then from there, you go to, you tell maybe Grok that all the questions on that topic from 1978 to 2025, you should generate it for you. And it will search all the websites. That's what this one does. It will search all the websites and it will give you all those questions, JAMB pass questions. And immediately you are through, you solve it. You are interacting with someone, so in that sense now you don't get tired. You don't get tired. There are logics to read, especially in this developing world. In this world of tech, many of you still be complaining that you don't know book. In this world of tech, I told you some times ago that a time is coming that all of you, that's why I was saying it, a time is coming that tutorial will no longer be relevant. All these tutorials will no longer be relevant. So that's why you have to grow. And if you are not growing now, when you get to university, you might start having issues. There's co-pilot. The one I used the most has been co-pilot, but they all have different ways of functions. During my exam now, I will just upload, especially all those biology stories and all. During my exams in UI, I'll just upload the whole book, upload it on co-pilot. Some I will ask them to summarize it. Some you cannot upload, they will not accept it. Then we did, I think it was all these things on fungi, bacteria, viruses, a whole lot of stories. And it will take me time. And I just copied the notes, then I uploaded on Copilot. I said you should summarize the important points. Then after summarizing, then on the whole notes, I said you should develop various questions. Then start solving those questions. And I did my exam well. So then look at all these tools now. How many of you do you have? Some of you, if they go and check what you are even asking ChatGPT now is rubbish. Go and check your history. Chats. Whenever I want to, some of you got this log message, you will say chat to help you to compose. Can you compose a suitable log message for my friend? I said, no problem. I'm here for you. You can reach out to me anytime. So please, there are a lot of tools you can use to learn. You don't need to go and be a computer guru. There are a lot of things, ways you can learn these days. So help yourself. Your purpose in primary is to grow. You being in class is just to have an interaction. But the way things are going now, and it's one of the things you are learning now that I'm telling you now. So please, that's one. Then secondly, we used to have 200 questions when it's close to mock and when it's close to our exam. So by March 20th, you would have seen the posts I shared. So by March 20th to 25th, I think JAMB mock is on 26th, Abby. So by March 20, is it 28? Did you confirm it? And we can still have our mock this period then. So we have our mock 20th to 25th. Now, the mock is always to 200 questions, so we do it every year. Now, the 200 questions help you to cover we try to make sure it covers syllabus. So for chemistry, you will have 200 questions. So that can be day one on the 20th. You start in the morning, immediately you are through, you do all the corrections, you talk about a lot of things in chemistry till evening. Anything, just your questions will help you to do more of revision, more of where have I not studied, more of this, more of that. But we will try to make sure that the 200 question covers the syllabus. So you do that. So we do that 20th to 25th. Each day used to be 1,000. That's how we used to pay. So for day of chemistry, it's 1,000 that day. So your questions will be printed, you write the exam, then after the exam, it's 200 questions. If you write your mock, normally it's 180 and 160 questions. So this one is just for each day. Then you write it, you do corrections, teachers explain everything again, you ask questions. Then after we are done with everything, then you go for your mock. So if you're able to solve these 200 questions and you prepare, that's why you should prepare towards this now, towards 20th. Find every means to cover your syllabus towards this period. Just do everything in your power. Don't wait for class. Get syllabus. So do everything. Aim at these 200 questions, I want to score everything. So that on that day, when they are doing corrections, then anything you really do not understand better, when your teacher is explaining, it will not take much time, because you have also done your own part of preparation. So that's that. Don't forget that. Then there's something that came to my mind just now. So after that, we'll tell you when we'll do that one for JAMB. And to those of you that probably you were unable to register for mock, it happens every year. Sometimes you would have even paid for mock, and at the end of the day, you won't be able to register because of time difference. This one now, the mock was just there when we're doing registration, but they didn't allow us to pick centers. And sometimes Ibadan would have been filled, and we have to pick maybe Ogun State or Ogbomoso or anything. And we cannot throw you at Ogbomoso except to decide that you have people there, you want to go there. So that's when we pick it for you. So, but the mock number one is majorly, most times, is majorly past questions. So it's not something you should bother yourself so much about. It's majorly past question. It's not everybody that will write it. Number two is that JAMB also wants to use it to test run the systems, to know how they operate. Is that taken? That's number two. So number three is just for you to also familiarize yourself with the system of things. Is that taken? And to make you know that, oh, I'm not ready for this thing. So that's one of the things you need to know about the mock. So
Bluetooth mode. Ready mode. Line in.
So, don't forget what we have talked about, so prepare yourself. So quickly, then another thing is, you would have also seen online, I sent it to your parents, your payments these days is only transfer. Whatever you want to do in Primax, maybe aside your jumps that you get, but anything you want to do is only transfer. So you get your books, mock, anything. The mock you want to write, the books and everything, you do transfer and you show evidence of payment. So you come with your receipt if you are done transfer to POS. Come with your receipt. The secretary will get your receipt, will issue you another receipt. Then you take that receipt to Primax. Then you get a card. That card will be stamped, and that's what will be given to you. So that's the way you make payments now. Is that taken? So God will bless all of you. So let's quickly talk about one or two things in physics. So these days now, you will still see some people being unserious. Please, it does not matter. There are different people with different destinations. So you are the one to know your own destination and know what to focus on. So I started current electricity in the last class. So let me quickly talk about what is left from current electricity. So if you would remember, I told you then that electricity is the flow of electric charges. We said current is the rate of flow of what? Electric charges. So we now said I is PQ dt. And from there, I showed you some symbols, Abby, we use, if you still have your notes with you. So I showed you some symbols we use in describing electricity. And from there, I talked about different type of circuits, right? Can you still remember? Yes. So we talked about short circuits, open circuits, and closed circuits. And at the end of the day, I explained resistance. And we say resistance is the opposition to the flow of electric current, right? Yes. Then I give you the factors that affect resistance. The area, that's the size, Abby. The area of overlap. We said, what's it called? The area of the conductor. The higher the area, the lower the resistance, Abby. So that means if the conductor is bigger, then electron can easily flow. And if the electron flows easily, then that means it will conduct easily. Fatima, don't go. So, then from there, we said the distance, Abby, the length of the conductor will also determine the resistance. If the length is long, then it will take the electron time to travel. And at the end of the day, there will be heating effects. And after that, I talked about the material, Abby, the nature of the material. I also talked about temperature. That increasing temperature increases resistance, Abby, for a metallic conductor. So you should get it right. Why increasing temperature decreases resistance for a non-ohmic conductor. So all of this is what I want to complete now. And then when I talked about electric currents, I told you what we use to measure electric currents. What instruments do we use to measure electric currents? Ammeter. And how do you connect? In series. The resistance of an ammeter should it be high or low? Low. It should be low. And you must be able to, your brain must be thinking about it as you are saying it. Why should it be low? Why should it be high? You understand what I'm saying? So, let's talk about potential difference and electromotive force. You have talked about this when you did electrostatics, but we need to know something about it again. Potential difference and electromotive force, and EMF. So, when you gave it definition during electrostatics, you said, this guy knows something, the symbol is usually V. This one, most times, the symbol is E. They are almost talking about the same thing. But let's see the difference. Now, potential difference is defined as the work done in moving a unit charge from infinity to a point. Potential difference is defined as the work done in moving a unit charge from infinity to a point. Or the work done across a load or an external load. The work done across an external load. The work done across an external load. You have done this, but I'm only giving that definition again. I want to find a way to still explain it, despite the fact that you have done it, so that everybody will still get what I'm saying. I'm not supposed to, because there's a way I would have explained it under electrostatics. But for now, just for the sake of this topic, so that everyone will be carried along, I want to find a way to explain it. So now, potential difference is defined as the work done in moving a unit charge from infinity to a point. And during electrostatics, you remember some things, test charge, moving towards the positive, and they tell you will the kinetic energy increase or decrease, and the potential energy relation, all those things. But from what we have here, what is the unit of work? Joule, Abi. What's the unit of charge? So, which means that the unit of electric potential is what? Joule per coulomb. But that joule per coulomb is called volts. It's called volts. So the unit of electric potential is simply volts. Is that thinking? So now, from what we have here, if I have a circuit, the one you need to understand, now, you know the symbols here, Abby. You still remember these symbols? This is the key, right? Is this key closed or opened? Which means that there will be battery, this bulb will come on. Abby, what does this represent? The resistor. Abby, now what does this represent? Ammeter, helping us to measure the current. This long part of this battery, what is the charge? Positive. Thank you. This part is what? Negative. Right? Which means that electron or charges will flow in this direction, Abby, and current will flow in opposite direction. Those were the things we did in the last class. And at the end of the day, they now ask you, what is the potential? Or they just say, what is the work done? You remember from the definition, I said the work done in moving charges, Abby, across from infinity to a point, or the work done in moving charges across a load. So let's say this part is A and this part is B. This bulb is coming on. For this bulb to come on, charges must have flowed through it. Electron must have been flowing, Abby. You know, if I close it, the bulb will go off. When I on it, the bulb will come on because charges are flowing. Now, they now say, what is the work done across this bulb? If they ask you what is the work done, then by experiment, we connect an instrument to determine the work done. That instrument is called a voltmeter. It's called a voltmeter. I will give you again. So the work I do across this bulb is called potential difference. So your question, they can calculate, they can say, calculate the work done across resistance R1. That needs to also be done across it. So let me just call this one V sub R, meaning that the work done across the resistor. I can call this V sub B, meaning the work done across the bulb. Do you get that? As the battery is too, there can be work done across the battery. So if I want to measure the work done, I can still connect a voltmeter. Don't get lost yet. So let me say this of C, meaning that let me even use this of small r. Then I can determine the work done across the battery. So anytime they say calculate work done across something, they are talking about what? Potential difference. The work done in moving a charge from infinity to a point. Now, how do we determine this work done? So right, potential. A voltmeter is used. A voltmeter is used. A voltmeter is used to determine potential difference. A voltmeter is used to determine potential difference, and it is always connected in parallel. It must be connected in parallel. The voltmeter is used and it must be connected in parallel. Let me quickly explain that before I explain the resistance part. Now, unlike this guy, you remember I explained something in that last class. I explained parallel and series. And I said that ammeter must be connected in series. And I told you why. If you still remember. Do you still remember? I told you that if your ammeter is connected in parallel, let's say the current is coming like this, and there is a junction, and at the end, it's now branched. So 10 ampere is coming. Then when it's branched, let's say 7 ampere is going through here, 3 ampere is going through here. This Guy, let me just put an ammeter here and put an ammeter here. At the end of the day, looking at these circuits, I told you how to differentiate parallel and series. I said the moment you see the current coming and it gets to a junction and it can branch, the moment you see branches, then that means that that guy is in what? Parallel. So these guys will be said to be in parallel because there's a junction that divided the current. So some parts can come here, some parts can go there. Now from what we have here, if I plug my ammeter here, what would this ammeter read? It will read 7 ampere. That's what we talked about the last time, Abby. Yeah, it will read 3 ampere. But as 10 is coming this way, it did not branch. Then I connect my ammeter. What do you think this ammeter will read? It will read 10 because the entire 10 is what is passing through it. Do you get that? I'm only repeating what I've said before. That's why your ammeter must be connected in series, not in parallel. Do you get that? So it must be connected in series so that it can read the entire current. Now, but let's look at voltmeter. We said something. How must your voltmeter be connected? Why? You know, this is the bulb. What did I call potential difference? Work done across this guy, Abby. Now, if I want to get the work done across this guy, we said it moved from a point to another point. So I want to know the potential from here to here. So I will connect a wire here and connect the wire here and connect the instrument. So that can help me to tell if you move from here, from point A to point B, you have changed your distance, Abby. I can calculate the work you have done across this place. If you started with 10 joules from here and you have 100 joules here, what do you think would have been the work you have done? 90 joules, Abby. That means covering from here to here will be 90 joules. If you talk about the change in work now, because you have to go from here to here. So it is between this point and this point. So I want to determine the work done across this guy. Then I will use this of B. Then which means between this point and this. So I have to connect it in parallel. If I put my voltmeter here now, it can't determine anything. Because it's just at one point, Abby. Oh, it will only give me the potential at that point. But what work do I do from here to here? Then I have to connect it in a way that it can help me measure between here and here. So it can tell me what I've done from here to here. Do you understand what I'm trying to show you? That's why this one must be connected in parallel. But if you don't have understanding of that, I'm only still trying to paint this. There are some things you should have done under electrostatics that I believe Ife would have explained some parts to you. But I'm only still trying to find a way to just explain it for you to follow. But if you do not get what I'm saying, listen. Anytime they ask you, how is your voltmeter connected? That's what you need. Every information is not gotten all at once. So, but you just need to know. So it must be connected in parallel. Now, how do I determine this potential? Using calculation. So we have what we call Ohm's law. So let's quickly define Ohm's law. Ohm's law. I will still explain EMF, but I'm trying to take it step by step because they all go into each other. And if you can't be calm to look at it differently, you might not really get it. So what does Ohm's law state? So right, Ohm's law states that the currents flowing through a metallic conductor, the electric currents flowing through a metallic conductor, the current flowing through a metallic conductor is directly proportional to the potential difference. Is directly proportional to the potential difference provided temperature remains the same. Is directly proportional to the potential difference provided temperature remains the same. So the current flowing through a metallic conductor is directly proportional to the potential difference. provided the current remains the same. I mean, the temperature remains the same. Now, if they ask me to determine this, the work done across this guy, I'm going to follow Ohm's law. Ohm's law made me to know that the current that will flow across this place will be directly proportional to the work you do. And that current is going to be a constant to be introduced. That's 1 over RV. That's the constant. So if I make V the subject of the formula, I'm going to have V is equal to IR. This is an important formula in electricity, just like F is equal to MA in motion. So V is equal to IR. You need to note that. Your I is the current that is flowing through that circuit. Your V is the potential difference. Your R is the resistance. So look at this now. If I say determine the work done across this guy, that means what will be your formula? You will use V is equal to IR, Abi, across this resistor. But this bulb, the bulb has its own resistor. This bulb has its own resistor. So they say calculate the work done across the bulb. That means we cap V is equal to I current flowing through the bulb multiplied by the resistance of the bulb. That's where your focus will be. I hope you are following little by little. Open your mind though. Calculate the work done here. V is equal to IR. If you know R, Abi, and you know the current that is flowing, then you can do that. And a lot of you that are sleeping in class, this is Monday morning. And I'm 100% sure that majority of you, TikTok level, module, I'm 100% sure. Majority of you, I'm not saying all of you. Majority of you, instead of you to read TikTok, and you got glued to that TikTok, that you are just laughing like a goat all night. Then you now went to sleep, or you did not even sleep. You are now coming to class now, you are sleeping. All of you better be careful. All of my coaches here. You know, those days, if our parents that did not go to school, they survived it. They survived it. Because there are a lot of them that did not go to school. So going to school then was like begging them those days. I remember even when I was very young, when my uncle gained admission, JAMB brought admission letter to our house. Continue. JAMB, his admission letter like this, I remember that day, it was a mailman that came, and the man brought the letter that you have been given admission here and there to go to school. These days now, they give you admission in 2 weeks, you don't accept it, they remove it immediately. They give someone else. Things are changing because a lot of people are going to school now. Those days, go and ask our parents, our grandparents. Immediately they are through with school, they will give them a house, they will give them a car, and they will give them a job. Immediately, they used to beg them to go to school. So not going to school then was a norm. Because most people were not educated then. But in this generation, if you are not educated, you will see in the next 5 years, you will know the difference. You will know. Shebi, they are begging you. It is law that they will be using to do everything. Everybody will now know the law. Yeah, this one says this one says this. Everybody will be talking. You that you feel like you don't have sense, you carry the lock yourself. Because things will change, and the dramatic change will be so great that you are going to see it. So all of you should work. Education is your bedrock. Work. Be sitting down on TikTok. Let people that are making money be making their money. You be sitting there and they be using your brain. So, if you don't know the right thing to do at the right time, you will now come to class on Monday morning, you will now be sleeping. As much as possible, I don't go against you people having fun. Don't against you watching your TikTok see it on Facebook, because we too, we are doing content. Who will now watch it? Who will watch it? I don't go against it, but do it at the right time. Laugh at the right time. Maybe when you know you are sad, small, laugh small. You had a boy that they said that went to drink sniper in UN, a medical student, just this last week. I don't know what is happening to him now. I pray that he survives it. But the point is that all of you now talk sniper to normal Jews. Sniper, echo. Show that on TikTok. All of you have been watching TikTok. I did not see that thing on TikTok. I just saw a news on it. So please, it's okay. I program. It's okay. The most important thing is don't take your life, especially for exam sake. Not for any sake, I'm not saying for any sake, but for exam sake. If you know the rate at which people are failing in life, you will know that it's not even worth it to think about taking your life. Go and ask, that's the problem. Many of you just want to copy people's success. You just want to copy people. You don't know the struggle they face every time. Many people are doing fine now. They are doing fine. You see a nurse, you see a doctor, you are seeing them doing fine. You want to be like them. And you don't know their struggles in life. Then you now pull Toribo. Then your friends will be encouraging you, this and that. And at the end of the day, you now fail one course. You now want to go and drink sniper. It's funny. The person that had E that time now, that killed herself now, the word I've forgotten now, wait a minute, if I get to the department where I don't share them. So you better be careful. That's why even you can read that way. You can read. My roommates then, failure was normal. Bayo can go. It's normal, like in health sciences. Bayo reads for 24 hours. Bayo does not play. He does not do anything. We are roommates. He's my very close friend. Almost every time he's in Faj Cave, reading. He was in pharmacy. 24 hours. And he will write the exam, he will still fail like 2-3 courses. And when he fails, they will do receipts. They used to do receipts. When all the mates are gone on, he will receipts. He will be reading again. And those are the norms. So, now imagine ẹni tó ti fail jam, ó wá padà ní medicine at the end of the day, ó fail, ó wá fẹ́ lọ poison rẹ̀. Kò bá ṣe bá lè lọ gbàgbé, ṣé dandan ni? I can't go and take. Some of these things are not easy, especially those of one of the things is that those of you that you care about what people say about you are your problems. That's where the problem used to come. Because you failed, and your classmates now, you now start thinking about people that will start thinking that Asholo do me, but then Ojolo do. But then you can fail. Anybody can fail. Just keep trying your best. You not go and kill yourself over what. So please, be encouraged to work hard. So at the end of the day, our V is equal to IR, and we can use it to determine anything. You know why I like to sometimes when I'm teaching electricity to be talking about one or two things, because when they start asking you questions, that's how you can attack it. They can just give you a circuit and say, determine the work done in R1. So you have to think about, how do I get the current that is flowing in R1? Then how do I know the resistance of R1? Your brain now start thinking. That's the ways you face all these problems. Only conductors are conductors that obey. Only conductors are conductors that obey Ohm's law. The voltage is coming from the cell. Sir, I don't get it. You coming from the cell. Sir, I don't get it. You get it. You get it. I've not explained EMF. I know I'm taking it KKK. I know I'm taking it like that. I've not explained EMF. She gets, so you will get it soon. I will still come back to this, but one word around. When you know I've explained resistance before, I've explained currents before, and that's why I explain this now, because you should understand what I'm multiplying here. So, but there are still some things I will talk about. That's what they used to say. So for ohmic conductors, there are conductors that obey Ohm's law. So, and the V for the graph, if you plot the V against I, then you remember that V is equal to IR, Abi? So R is going to be your slope. R is going to be called the slope. The graph for Ohm's law is a straight line graph, because as you increase voltage, current also increases. And for a straight line equation, we have y is equal to mx plus c, Abi. If the intercept is 0, then that means c here is 0. So y is what is on the y, and that is v, Abi. The m is slope. X is what is on the x-axis. What is here is what is on the y-axis. That's your y, v. This is the general equation for a straight line graph. So anything that is here must be what is on your y-axis. Anything that is here must be what is on your x-axis. Then here is what is the slope. The slope. If you did physics practical yourself, you remember that your slope is always change in y over change in x. Abi, that's your slope. So, but from what we have now, so from here to I can say y over x if this one is 0. So in this case now, my v is equal to IR. So if they now ask you, what is on your y-axis here? V, Abi. What's on your x-axis? What is your slope? R. Do you get that? But if they plot the graph like this, so they can ask you that, what is your slope? If the graph is plotted like this, I against V, and they still give you a straight line, meaning that your what is on your y now is going to be high, Abi, and what is on your x, let me rewrite it, V is equal to IR. And you remember our equation is y is equal to mx plus c, because the intercept, so this place will be taken as 0, because this is like plus 0. Check it, there's nothing there. So now from what I have here, is it V that is on my y? So what should be on my y? Which means I have to rearrange this formula. Do you get that? So I have to make this formula, I have to say that I is equal to V over R, Abi. Now, to make it look like this guy, I will simplify it. So I can say I is equal to, I is my y now, but I need to know what my m is, because V is for my x, Abi. So I can say 1 over R times V. Do you agree? So this one is like y, this one is like your m, Abi, and this one is like your x. Are you following? So if they plot I against V, that means your slope is inverse of what? Resistance. Did you see that? If they plot V against I, your slope is resistance. All these are important. It does not only apply here, it applies almost everywhere. Are you following? So for a straight line, M is equal to this. So your slope here is resistance, your slope here is 1 over R. I only made them the subject of the formula. This is a general equation for equation of a straight line. So now, we have what we call non-ohmic conductors. Non-ohmic conductors. Are you following? Oh yeah, draw the graph. Study it. For non-ohmic conductors, these are conductors that do not obey Ohm's law. They are conductors that, examples of ohmic conductors are metals. All metals are ohmic conductors. Is that taken? So you should write that as part of the examples. Your metals. There are semi-metals. Some semi-metals are usually semiconductors. So, all metals are ohmic conductors. So, God dragon. Is that okay? I want to, have you written for non-ohmic? So non-ohmic conductors are the ones that do not obey Ohm's law and majorly due to temperature and all of those stuff. So for non-ohmic conductors, examples, incandescent lamp, your lamp, filament lamp, diode, transistors. You are still going to talk about diodes and transistors. Electrolytes. They are non-ohmic conductors, so they do not obey Ohm's law. So when you draw their own graph, it's not even a straight line. When you do semiconductors, you are still going to draw graphs and all. It's not a straight line. So if you plot the voltage against I, it does not give you a straight line. But for ohmic conductor, you have a straight line. So when you do electronics for diode, there's a graph for them, which they might ask you. So when you get them. So just know the most important thing is that for non-ohmic conductors, the graph is not a straight line because the voltage and currents are not directly related. So let's now go back to this, now that we know Ohm's law. Let's now go back to potential difference and EMF. Can I rock the board? So, what's now the difference between potential difference and EMF when you hear it? We already said potential difference is work done in moving charges across a circuit, across a junction. Now, the difference is this. Let's say I have a resistor here. Forget the bulb now, and I have a battery. And current is flowing in this circuit, current I. There is what we call an internal resistance. So let me quickly give you a definition of internal resistance, so I can explain it better. If you have done electrolysis, you will understand how a battery works. But for now, right? Internal resistance is the resistance of a battery. Is the resistance of a battery in a circuit. Is the resistance of a battery in a circuit. And work must be done to overcome this resistance. And work must be done to overcome this resistance. And work must be done to overcome this resistance. The internal resistance of a battery in a circuit, we use small r. And work must be done to overcome this resistance. So, this internal resistance is in the battery. The same factors that affect resistance, like area, affects internal resistance, area of the electrode. If you have done electricity, you remember how battery works. There's a salt bridge. You have not done electrolysis in chemistry, have you? That's what you are supposed to do after oxidation and reduction. That's a galvanometer. So, depending on how these things are arranged, then the distance, this thing is going to join them together like wire. So the length also determines the length. Some things happen in the battery. You might know if you have not done electrolysis. One of them is called anode. One of them is called cathode. And a lot of things can happen. There's what we call this polarization. Abi? We will do them later, so don't worry. There's polarization, there's local action, and all. All these things can affect how a battery functions. So, how the battery functions now, and the effect of all of these things is what we call the resistance. Now, this is a resistor. I have to do work across this resistor. So please listen here now. This is what you need to know for this class. You will know these ones later. Now, for here I have V sub R. If you are going to say it now, what does the V sub R means? You better say it, because Coach Mama Rick said already about in the time exam. What does V sub R mean? If you don't know all these things, you don't know anything yet. What does V sub R means? It's like I have to be calling you one by one. What does V capital means? Look at your number. If it is for you to laugh on TikTok now, we will hear all your voices. I've been explaining the same thing since morning. What is this measuring? I don't know why many of you are not talking. Some of you are talking. It is the work done across R, Abi? Yes. That's this. This symbol that is here, what does it represent? A voltmeter. How is it connected here? Parallel. These are questions that we ask you. But in calculation term now, this is known as the work done across the resistance. Abi? And now, work done across the resistance. That means, what formula will it be? V is equal to IR. Which I is this? The current coming from the battery. Abi? Yes. And that's why you have to understand something. As this current is coming from the battery, you know we will use current that is flowing through the resistor, I. But this guy is connected in parallel, which means it might draw current too. This one is for people that have understanding already. You might not need to think about it. Because I've connected them in parallel, as this current is coming, when it gets here, what do you think will happen? It will divide. And when it divides, let's say that what is coming in, let's say these ohms, the R that I'm given here is 2 ohms. And the current coming is 10 ampere. When I put this instrument, or when I measure, I'm expected to have V is equal to 10 times 2. Abi? That means the work done is supposed to be 20 volts. But there's an error. As this 10 ampere is coming, when it gets here, let's say that 8 ampere is going through here, and this one is drawing 2 ampere. At the end, that means my V is now going to be current going through our Abi, 8 times 2, and that's 16 volts. That means that this thing is not accurate. So there's an error, there's an issue that they commonly ask in JAMB. That why do you have to use a potentiometer? I will get there. So just keep following these stories now. The story might not be for all of you. It's not all of you that have that understanding yet. And sometimes when we say it, it always looks like, I know in secondary school, probably they just tell you V is equal to IR, you just draw your graph, you do your calculations, and you move on. But the only way you can be scoring above 300 and something in JAMB is when you have interpretations of what you do. You have understanding of what you do. So, this V here draws current. Let me now ask you a question. If I want this thing to be accurate, I want it to give me exactly 20 volts. I have to use a resistor inside this guy. And you know the function of a resistor? Resistor does not allow current to flow. Abi? Now, if I want it to be accurate, do you think I'm going to use a high resistance or a low resistance? High. Why am I using high? Because I don't want this current to be dragged. If I use a very high resistance here, that means that no current will flow through here because this guy will not allow current to flow. That means the whole thing might eventually pass through here. Are you getting a bit of light? Now, but if they now ask you, the first question they can ask you is, how is your voltmeter connected? Parallel. You remember when we talked about ammeter, how did I say it's connected? Series. And the resistance for ammeter must be what? Low. Why must it be low? Because we want to measure current, and the current must easily pass. Abi? But now I want to measure work done across here, and these guys must be connected in parallel. But if it's connected in parallel, there will be an issue, because the current that is coming, that I'm supposed to measure within this guy, is going to be divided. And when it's divided, there's an issue. It will no longer be accurate. So now the question is, what can I do? After connecting it in parallel, I must design it with a very high resistance. So that if the resistance is very, very high, even if it's going to draw current, it's just going to draw very, very little. So this guy will be an approximated answer of 20 volts, and that will be perfect for me. So the next thing you need to note is that, what did we define last? Ohm's law, Abi? Internal. So don't define this yet, so that you will not join them together. But the major reason I'm still going like this is this. Notes. Just write notes. I could have said something straight, but breaking it down is the best, especially this topic. Notes. Voltmeter must be connected in parallel and must be designed with a high resistance. And you should know why. Anytime they ask you anyway, why must your voltmeter be of high resistance? Voltmeter must be connected in parallel and must be designed with a very high resistance. So let me just introduce something to you from here. Must be designed with a very high resistance, full stop. This is why there is no ideal voltmeter. Write it that way. This is why there is no ideal voltmeter. This is why there is no ideal voltmeter. And there is need for a potentiometer. This is why there is no ideal voltmeter. And there is need for a potentiometer. So let me just tell you what that means. Voltmeter, no matter what we do, it will still draw current. So that error cannot be totally neglected. We now have to develop another instrument that can help us to measure the work done across this guy accurately. And that instrument is now potentiometer. So they can now ask you in the exam, your potentiometer works as an ideal voltmeter when 1, it has a high resistance, 2, it measures internal resistance, 3, it does not draw current. Why are we using potentiometer in place of voltmeter? Because potentiometer does not draw current. That's not how it works. But for your voltmeter to work, it will draw current. Have this understanding. It's not everything that you will see in textbooks. The story I'm saying now, you can't see it in any textbook. This part. You will see it in books, so maybe if you read all wide. But for these books you are reading, you apparently might not see those stories. You might just see that your potentiometer does not, must have no deflection. You might see that, but you will be surprised at what does this mean. What does it mean? So, shall open your mind. Now, this is a resistor, and this is the work done across the resistor. So in these circuits now, Let's go back. So in these circuits that I have now, in most of your calculations, they can say neglect R. What is our small r? Internal resistance. This is capital R, Abi. The work you do across this R, we call it V sub R, Abi. Now, this guy is called external resistance or external potential. I can determine the work done across this guy too. Then I'll call that V sub small r because of that internal resistance. Then V sub small r is like your internal work. Most times this can be called your back EMF or loss voltage. Loss voltage. You will see why it is lost soon. Now, if they now say determine the work done across the cell, it's another statement. Determine the work done across the external load is another statement. Determine the total work done. That's when they are talking about this guy. And determine this, they can say potential difference across the load. But EMF of the cell, everything that is happening in the cell, that's when EMF comes into play. But if you hear potential difference, they are talking about external things. But if they are talking about EMF, they are talking about total of everything that is happening. So, if I want to get that of this external resistor, my formula is going to be V is equal to IR. Do you agree? If I want to get that of the internal resistor, my formula is going to be V is equal to I small r. Abi? I hope they are following. But if they now say I should get the EMF, that means EMF will be the total of VR plus V small r. And they are both in series. So, define it. Let me ask you a question again. What's the difference between EMF and potential difference? Potential difference is always described as the work done in an external circuit, while the total work done in the whole circuit, that is what? Your EMF. So you say EMF of the battery, because what is doing the entire work is the battery, Abi. Or you say potential of a resistor, or potential of a bulb. Bulb is outside, resistor is outside, any other thing that is outside, you say potential. You don't say the EMF of this. No question will say determine the EMF of the resistor. No. They will say determine the potential difference of the resistor. But if they want to talk about everything in the circuit, they will say determine the EMF of the circuit. So what I've done here might be more. VR plus VR, you will just add everything together. But for now, let's stay on simplified way. So right, EMF, electromotive force, from the word electromotive force, is the work done in moving charges, around a complete circuit. Work done in moving charges around a complete circuit. The time is what? 11. 9:10. So we can finish this soon. Then I'll quickly tell you how to buy electric energy and power and solve questions on everything. So my own JAMB now, I saw a lot of questions on electricity during my JAMB, and a lot of questions were tricky during the exam. So that's why you have to have understanding. I saw 2 boys talking when I was coming from the exam hall, and I saw them. The way they were talking, you know that these boys are brilliant. You know. we were analyzing all the questions and we were all coming together after the exam. Then I did not have car, so I just first anything. I should party exam. And at the end of the day, as we were talking, I was following them as we were talking. And they got to one of the questions we saw in electricity. And one of them said that the answer is 2. The other one said the answer is 4. And they started analyzing the circuits. I was looking at them. Nice one. We did that, no? And they know it. They know it. It's not like they do not know it. But the way the diagram was drawn was to scatter everything. So if you do not calm down to do some sorting, you will not get the answer. And that's why that one was saying that this, then I told them that this is the answer. Did you check this? Did you see this? Did you see? Say, ooh, don't worry. When we got to Lanogo and tell me. So, but that's the point there that you can know something. If you don't have the connection with it, like you yourself being connected to that thing, understanding what is going on, it might be tough even when you solve questions. So, I said EMF is what? Work done in moving a unit charge around a complete circuit. And a complete circuit. So we call it EMF. It is also measured in volts. So the unit is also volts. Now listen. If a questioner says that neglects internal resistance, that means your EMF will just be equal to VR. Abi, everything here will be 0. Do you get that? But if they do not say neglect internal resistance, that means E will be equal to VR plus V. Then that's why we have this. So this is the external voltage, this is the internal voltage, and this is the total voltage. Do you get that? But now, this is another issue with this. Do you know why we are calling it loss voltage? Because they can ask you to calculate loss voltage. Let's say I have a resistance of 10 ohms. I have a battery, and this battery does work of 12 volts. And when it runs, it's going to give me a particular current. Let me just use this to determine something first. I is going to be V over R. 12 divided by 10. That's 1.2 ampere. Abi? So let's say it is 1.2 ampere current that is flowing. The current flowing through the circuit is 1.2 ampere. Now, naturally, if they say you should determine the work you have done here, you know, V is going to be equal to IR. Abi? At the end of the day, my I is what? 1.2. Abi? My R is what? 10. What will I get? Abi? Now, what do you notice here? The same voltage of the battery is the same external work. The battery is working on this guy. But because I did not put anything like internal resistance here, so E is equal to VR because the internal resistance is taken as 0. But now, let's imagine that the internal resistance is given as 0.5. As small as, let me even make it 0.1 ohms. They now said calculate the voltage loss here, the voltage in this place. Or better still, this is 12 volts. The current flowing let's calculate the current flowing in the entire circuit first. So that means I have internal resistance, AB, I have E, then I have R. Are you following? So if I'm to calculate current, say, what will I do? I will use E is equal to VR plus VR. Are you following? Now, what's my E? 12 volts. VR is what? IR, not 10 volts. I hope you are following. It is R that is 10, not V. Plus I small r, right? So at the end of the day, I'm going to have 12 is equal to I or 10I, right? Plus 0.1 I. So I can make I the subject of the formula. So 12 is going to be what? 10.1 I. Do you agree? That means my I is going to be 12 over 10.1. Please do that with calculator. Let me make it 0.5 so that it will be significant a bit. Please make it significant. Make my small r 0.5. So this one will now be 10.5. Oh yeah, 12 divided by 10.5. Shewa 1.143 ampere. Now that's the current flowing in the circuit now. So if this is the current flowing in this circuit, they now say, you know your battery is 12 volts. What are you supposed to get for this normally if the internal resistance is not there? 12 volts. Abi, that's what I just proved first. But now that there is an internal resistance, something has changed. Now let's calculate the voltage drop here now. We have known the current flow in Abi, and the current is now 1.143. So we can calculate voltage drop here. So voltage drop in the external resistance is going to be IR, Abi, and my I is 1.143 multiplied by what's my R? And that will give us what? That's 11.43 volts. Note something here. Is this up to 12 again? Why is it not to 12? Who can explain it? So which means that out of the 12 volts that the battery has, it has used a part to work on itself and use the rest to work outside. I hope you can see. Now, let's calculate the one that it used to work on itself. That would be VR is equal to IR, Abi, and that means what's my I? 1.143 times what's my R? 0.5. What would that be? 57 volts. So which means that out of 12 volts that you are expecting to do job for you here, you have lost 0.57 volts. So the one you have left is what is doing your job, and that's this one. I'm only using this analysis for you to understand when I say lost voltage. So where I started, without this R, I had 12 volts. Abi, without the R, I had 12 volts. But now, because of this internal resistance, it has lost a part. Do you get that? So what I'm using to work outside now is no longer up to 12 volts because the battery has to work on itself. Then that takes me to another thing. So you understand why we call it lost voltage now? So they can ask you to calculate the lost voltage. So now let's look at another thing quickly. When you start practicing questions now and start applying your brain to it, you will see that this thing is not that hard. It's not that hard. You are the one that is making it look like it's hard. It's hard for learners, for beginners, yes. Even some of you, after all this sweating, talking, you might still find one or two things tough. But just try solving questions. So now, let me explain something further. Are you true? So write this question. Okay, there's something I wanted to explain to you on EMF, but I pray that I will remember after this question. A circuit with an EMF of 24 volts, a circuit with an EMF of 24 volts has an external resistance of a circuit of an EMF of 24 volts has an external resistance of 12 ohms. As an external resistance of 12 ohms. External, where was that? It's not easy to see love letter. You'll be blushing. Don't worry, you will get it. Oh yeah. And an internal resistance, of 0.45 ohms. Internal resistance of 0.45 ohms. Determine the loss voltage. Determine the loss voltage. Oh yeah. You have 2 seconds to do that. Determine the loss voltage. If you have been listening to me since morning, everyone should be able to solve that. Except you have not been listening, you should be able to solve that. Well done. Have you all got seen it? What's the answer? 0.864, 867. What's the units? So don't just tell me 0.867. Always add units to it. In physics, even in the word, your value has no meaning if it has no units. 1,000 naira. You know what it means. It has units of naira. $1,000. You know what it means. Where I came from too, from the United States of America. Awoji, adigidi, masu, wake up. So, did you all get the answer? Ìgbà tó kọ ẹ̀yìn sí class. You are back in class and you want to get the answer. Àwọn tó kọ wájú sí class náà. So now, you were told that you have a circuit, Abi. You were given the EMF. What's the EMF? 24 volts. What's the external resistance? 12 volts, right? What's the internal resistance? 0.5, right? Right? Then that means you can say, please, in physics, if you see that the story is getting somehow, you can try your best to draw diagrams to make it clearer to you. So I can say that my I is equal to E over R plus R, Abi, and my E is 24, then 12 plus 0.45. So what will I give you in total? Okay, 9277 ohms. So now that you know current, you can know V now, Abi. So V sub R is going to be I R, and that's 1.9277. And that gives what? So now, imagine a question now says that neglect, even after they giving you, they gave you the internal resistance to the 0.45, but further on in the question, they now say neglecting internal resistance. But the neglecting internal resistance is what you neglected. And you went to some question, and you came out happy. Be careful. Even though they supplied you, but they now still said along the way in the question that neglecting internal resistance determine the potential difference or the external voltage. So in order to determine external voltage now, you already know that the voltage of your battery is going to also be external voltage. You just pick 24 and you move on. I don't know if you're getting my point. If you don't have all this understanding, your exam can be very simple. But if you are not smart, they want to test that. So I can give you a question and ask you to calculate the external voltage. And I also give internal resistance. And I now still told you to neglect that internal resistance. But you are feeling like, some test me, my answer is 24. And that other answer, if you multiply minus 24 from this now, it will be the option. So please, it's not just to read, apply some senses to it. So let's move on. So now, we've said something that, please, everybody should come back to class. We said, look at this. This circuit has an internal resistance, then it has this thing closed. It has an external resistance. Let me ask you a question. I put a potentiometer here or a voltmeter. Then I measure this. You already know what that will measure for me, Abi. What would that measure for me again? Someone just said EMF. Is this EMF? No. What will it measure? What done across the resistance? I want to use it to explain something to you. If I plot this now, plug this to this, what is this one measuring for me? What done across the battery. But now, this, from that question we just solved, or let me say from here, we got this one to be 11.43 volts, and we got this one to be 0.57 volts, and in total that means what this battery is supplying is, that was what we did. Now note something, please. So these are questions they ask you. Now note something. Look at these circuits now. I put my voltmeter here. Then I also put my voltmeter here. For this one, with this same set of values, what do you think this one will read? What do you think it will read? What do you think this one will read? Now, look at what it is here. This key is opened, Abi, meaning that current is not flowing across this guy. And if current is not flowing, that means I is 0, Abi, and V is equal to IR, 0 times whatever resistance is 0 volts. That means there is no voltage loss here, Abi. But if you want to measure the voltage across this guy now, everything you will get will now be 12 volts. Because you know the battery measures what? 12 volts. Now you are not doing any work outside. So the entire work this battery can do is what you will see. I hope you are following. You know, normally what we did here was that when we connected the circuits, this one was able to read 0.57. Why? Because out of 12, you have used 11.4 here. So what is this one showing you? What is left? So compare them. But now, in this case now, this circuit is closed, this circuit is open. So you did not use anything here now. Everything is 0. Then what this one will show you in total will be 12. Is that English too much? Let me repeat myself. In this place, what's the power of the battery? What's the voltage of the battery? 12 volts. So if I plug a circuit, this thing here, I'm supposed to read what the battery can do. And what that battery can do is 12 volts. That's what I'm supposed to see. But now, when I plugged, I'm seeing 0.4757 volts. Meaning that out of the 12, something has used out of it. What did that thing use out of it? 11.43. Do you get that? But now, I now connected it in such a way that this one is not using anything. That means that because current is not flowing here, I is 0. So the voltage that this one will measure will not deflect, so it will be 0. Why is it 0? Because it's left opened. By the time I close it, current will start flowing, and I will measure something. Abi? But now it's opened, current is not flowing. Meaning that if I now check this one now, since it has not done any work outside, then the battery will measure its normal voltage, which is what? 12 volts. Do you get that? So, if a circuit is left open, you can measure the EMF of a battery. But if it is closed, no. If it is closed, that battery would have done work all around. So if you want to measure it, you can't get the value. That's the value. That's the points I want you to know. So right. Don't sleep. The EMF of a battery, the EMF of a battery is determined. The EMF of a battery is determined when the circuit is left opened. Most of you don't do experiments in your school. While you're in school, recommend You remember when you are doing physics experiments, they will tell you something. Before you start, especially electricity experiments, they will say, take your battery, connect it to the potential voltmeter, and determine the potential difference of that battery. You will now, after you determine it, you now write it on top of your table. Then you will now start connecting it. Before you start connecting, they will tell you to first measure, because they might have told you in your exam that school should supply you a 12-volt battery. Now that battery that they give you, immediately you collect it, you connect the wire, connect it to a voltmeter. When you connect it to voltmeter, it will read 12. But sometimes there might be error, so it might read like 11 point something or thereabouts. Then you will now record. The battery my school gave me is 11 point something volts. So in case the 12 volts you ask them to give me, this is the one they gave me, and that's what I will be working with. That's what you are saying on top. Then you now start connecting all your other components of the circuit. But it's not your fault. It's not your fault. It's not your fault. Primer still has apparatus if you want to learn. When after this class now, you can go and check. We have voltmeter, we have ammeter. Don't like contributor, Google whatever. So we have voltmeter. So we'll buy a battery, we'll connect it. Then we'll do this circuit connection, and you see, we'll now check what it will read at each point, so that you understand what we are saying. But you know the practical example. So let's move on. What's the next thing? Let's look at combination of resistors. So don't forget all those stories I've said. There are areas they can ask you questions, areas they can ask you to solve some problems. So combination of resistors. Now that we understand this now, we can combine resistors and we can now work with understanding. Combination of resistors. You did Sir, please, what is voltmeter? Voltmeter is different from voltmeter. Abibura. Voltmeter is a Daniel cell. When you treat electrochemical cell, that is voltmeter. So, can I rub the ball? Are you there? Combination of resistors. Now, your resistors can be connected in series and can be connected in parallel. The essence of it is that you need, let's say you need a 5 ohm resistor, and you know the function of resistor. You need a 5 ohm resistor, and you look into your lab, you only have 3 ohms and 2 ohms. You still have to work. So how do you do it? You combine the 3 and 2 in a way that it will give you 5, so that they can do the job they are supposed to do. That's the essence. One of the essence of combining resistors. So if you now want to combine, I can combine 2 and 3 to give me, I can combine 2 and 3 to give me a higher value, and I can combine 2 and 3 to give me a lower value. If I combine 2 and 3 and I want to have it as higher value, I will connect them in parallel. If I want it to give me a higher value, then I'll connect them in series. Let's see how that goes. So which means that if I want 2 and 3 to give me 5, I have to connect it in series, not in parallel. If I connect it in parallel, we have a value that is lower than 2. Now, for the connection, for the combination, I told you something. This, I call it R1. This, we call it R2. Then we have this. we have the battery, we have the key, the ammeter, and blah blah blah. So, ladies and gentlemen, neglecting internal resistance from all our stories. We are not even sort of 56 listen. So, neglecting internal resistance. What will be the total work done here? Normally, I'm just saying, what will be the total work done? That's like EMF is going to be VR1 plus VR2. Do you agree? Very good. That means there's a voltage across R1. Abi, there's work done across R1. There's also work done across R2. You will know book by fire by force. There's voltage across R1 and there's voltage across R2. And he said, what is the total voltage? That's EMF. That means I can say VR1 in a simplified way. I can just call this V1, meaning that this is R1. And I can call this V2. I hope you're getting it. So I can say this is V1 and this is V2. Now, the next question we would like to ask, forgetting these voltages now. This R1 and this R2, are they in series or they are in parallel? They are in series. Any current that comes like this continue to go, Abi, from R1 to R2. Forget the fact that because I put this on, some of you might be confused. Let me remove this one so that I will repeat it again. Because I know some of you are already looking at me. Oh yeah, Granot. Look at this. Current is flowing, Abi. R1 and R2, are they in series or in parallel? Series. It's the same current that pass through. Let me say this is the current coming from the battery now. Now, because both of them are external, my E would equal to external because there's no internal resistance. So I can simply still say my E is the same thing as V, but now V total. So in textbooks, you will see that V total is equal to V1 plus V2. What do you think this V total is talking about? The total work done. Abi, total work done. V1 is the work done across R1, which we can measure using our book. That's why this one is there. Do you get that? While V2 is the work done across R2. And we are able to do this all because there is no internal resistance. If you need to know the number of times I've said thank you, Lord, in my heart. Because I know the way I'm explaining this thing. If you are not getting it, you have been bothered because you need to have done all those electrostatics. I was telling someone this morning that because in the last class now, the way some of you were looking at me, like, how would I explain this topic to these children? And that's why every time I'm explaining, and there's a spirit in my heart that says that no, I'm explaining it well, and you are getting it. I keep saying thank you, God, in my spirit. You might not know, because you can't read my mind. You are not there. Anybody that is not getting it must have been someone that is not paying attention, or your mind is so closed, or you are just a very, you are a learner. Let me put it that way. You are a learner, and some things are looking strange to you. You are a learner, but don't be bothered. You will still know it. Just continue to try. I wish if I had seen people explain it to me too, like this, maybe. If they give us the current and they ask us to look for the internal or external resistance, but it is not possible for them to ask us to look for internal. When you start solving questions, you know if it's possible or not. Just apply your formulas and senses. So now, I can call this my V sub T now, meaning that V total. Is that the key? Now, this current is coming from the battery, Abi. I can say the current that passed through this one, I can call it I1. While I can call this one I2, Abi. So at the end of the day, if your question now says, determine the voltage across R1, what will your brain think about? I need to know the resistance of R1, Abi, and I need to know the current passing through R1. At the moment you know that, that means you can just say that V1 is going to be I1 multiplied by R1. Abi, if they say calculate the work done across R2, that means you will say V2 is equal to I2 multiplied by R2. Abi, if they say calculate the total voltage, that means you're going to say some of you are focused more on questions that will not be relevant now than listening. You will be given time. Normally, you add all your questions together. I will read it, but you add all your questions together. So what will this one be now? I1. It can be I1, R1, I agree. It can be I1, R total. This is V total. That means it's going to be okay, you are saying that I1, R1 plus I2, R2. Do you agree? Yes. Which means I can simplify this. I can say V total is equal to I, because I1 and I2 are the same. So I can put it together as R1 plus R2. Abi? Now, let's leave this one first. The major reason is that I'm not going to do it this way. I just want your mind to be at work. That's why I left it. But I can simply say this is I total. Do you agree? Or I can say this is V total is equal to I total R total. She gets. So this is where I want to work with, because we are trying to get something. So now, don't worry. So we can say V total is equal to I total multiplied by R total. Abi? Now, do you agree that I total is the same thing as I1? And is the same thing as I2? Because the current that is coming from the battery will not look by it, She gets. So if they are in series, whenever they are in series, it is the same current. So now, from here, I can say that V total is equal to V1 plus V2. Do you agree? Let's say this thing is 12 volts. If it does the work of 8 volts here, what work can it do here? 4 volts. The total is 12 volts. Total let in the shape 8 in B. That means pay for local total B. Do you get that? That's what we have been doing. The total work it can do is 12 volts. So if it has done 8 here, that means what is left here is 4. So now we can say this one plus this one will give us this one. It's the same thing we did here now. Shebon Lele into R1 plus R2. So this side and this side are the same, so they can cancel. So I can now R total to be equal to R1 plus R2. So whenever you connect two resistors in series, just add them together. So now, I said if I need the 5 ohms, I have 2 and 3. I connect the 2 and 3 in series, then I will get 5 ohms. You can see that 5 ohms now will give me 5 ohms is a value that is above 2 and 3. Abi? So I've combined them now in series and I got the higher ohms. So write this, then I give you 1 or 2 bullets. Are you ready? Are you true? Eh? Notes. So let's note something. One, note for resistors in series. When they are in series, what do you note? One, same current flows through the resistors when they are in series. Same current flows through the resistors. Have you seen that? We've talked about that. You were well done. Same current flows through the what? The resistors. Are you true? Number two. So which means that the same total current that is coming from the battery is what will flow through R1 and will also flow through R2. Abi? So same current. But their potentials are always different. And why? You can't compare, this one is coming from year to year, then from year to year. So and we say work done in moving from one distance to another. I didn't use that method to explain because something like this, and I'm moving a positive charge from year to year, and I'm moving a positive charge from year to year. The work I will do be. So the potentials across each resistor differ. The potential across each resistor differ. That means their potential difference differ. Math students, how far have you gone? Those that started though, not those that just joined last week. You say you have not gone far. She will prepare gone primary. Have you even gone far in primary? So, but either those that start around January or those that start around September. So how far have you gone? Your maths. Nobody is taking math, Abi. How is it going? It's going. You're almost through, Abi. Maths is not that much. And please note something, please, everybody. Please, biology student, keep quiet. Leave Emmanuel. You know that when you have a drum and that drum is big and you slap it like this, you know how the sound will be. But if the drum is tiny and you slap it like this, so you should understand what's happening between Emmanuel and the tiny person. So, for the engineering students, please, if you write JAMB, top 10 in JAMB used to be engineering. And if we also want overall best to come from primaries, we have been fighting for that. I wish I know maths very well, and I'm not actually ready. If I'm ready, I would have taken maths. But a lot of responsibilities lie on me. I would have loved to take maths because it's easier for you to score 100 in maths. It's easier compared to biology. No arguments. The beginning of maths, the only thing is that you cannot read maths on your own. You can still read biology on your own, even if you don't go to tutorials. You can still try your best to read biology on your own. But for maths, you need someone to teach you, someone to solve questions with, someone to brainstorm with. For JAMB mathematics, you can. So please, the moment you score 100 in physics, 100 in chemistry, 100 in mathematics, that's 300 already. Then English, 50 or 2. You can see, you see that you score 360, 70 in JAMB. It's not child's play. When you see someone scoring 372, last year someone scored 372. So you should know that it's not child's play. So before you can get to 300, before you get to 320, that means it's called 80, 80, 80, 80. That will give you 320. Let's not say you are very strong in physics. You score 97 to 100. It's a common score that those that are strong can have. If you are strong in chemistry, 98 to 100. It's a common score. Biology or maths. Maths, you can score 90. Let me just say 95 to 100. That you don't even know much, but you prepared very well. You can score 90. Add all of this together now. 97, so that's 196, so 291, 290. Imagine all these 90, 90, 90, 290. If you now score 50 in English, 50 plus 290, 340. Now score 80 in English. 370. Overall highest last year was 372. Pẹ̀lú ọmọ kan tó sọ yìí náà ó tún jẹ́ overall highest. Ṣòrí pé ṣẹ́ wà ń bẹ̀. So you have to work. You have to work hard. 1 month can do it. Do your best. Yorùbá will say that ohun tó wà níta ó ṣì tó aṣọ sá. Do your best. Like have that mentality. Pick up questions and solve. So please, you are aiming at 100, especially those of you that probably have written JAMB before. You are aiming at 100 in physics, 100 in chemistry, 100 in biology, 100 in maths. You can score 90 plus. I've had people score 90 plus in English before. I had a friend who is a teacher who teaches English. I have a friend that scored 92 in English. But since then, I'm not sure I've ever really seen anybody score 90 plus in English. So you can do it. And it's because you don't always put that energy in English. So please, number 2, what did I say? The potential difference across each resistor differ, Abi. So the potential difference across R1 might differ from the one across R2, all depending on the resistances. If the resistance is the same, then they will be the same. Number 3, the combined resistor or the effective resistance. The combined or effective or total resistance. The combined or effective or total resistance. The combined or effective or total resistance will be higher than individual resistance. Will be higher than the individual resistance. Someone is still pressing phone there. Is that where we cut from the hostel? Oh yeah, give me the phone. I went to their hostel yesterday and I was begging them to please drop the phone for me. So this one is after JAMB, where you can see the phone. And after the JAMB, just I not collect it. I don't know. Every time, one mama communicated, use your sense more. We are using mic and in class. So some of them are the back, they are just sleeping. I don't know. Then they should continue to sleep. Their results can sleep too. So the combined, we are using mic. There's nobody that will tell me you cannot hear from that back. So even if I'm using ordinary voice, you will hear. And from what I'm saying, look at your number. That's what they say. But I can't come to the back. I've been what is sweaty, dry. What's dry? What you just sweat to me like. So if I no more calm I already begged all of you this morning that some people are not here to learn anything. And no matter how you try for them, and come and choose them, so we can't kill ourselves. So what I said is that you can do that one. So let's do for parallel quickly. Let's say this one is 2 ohms and this one is 3 ohms. The combined resistor will be what? 5 ohms. Shake again. Now 5 ohm will be greater than 2 and 5 is also greater than 3. That's what that last statement is saying. They can ask you. So let's do parallel now. Question? No question. I'll combine all the questions. So for parallel, there was a student we had some years ago. I think she has graduated from Taiwan. Every time. To parallel, I don't really understand. So this is R1 and R2. There's still a total voltage. But what's the difference here? The work you do across this guy is the same as the work you will do across this guy. They are in parallel. It's like when you say something are in parallel, if one is like this, one is like this, one is like this, parallel. So the work you do from here to here is the same work you do from here to here. Abi, it's the same work you do from here to here. So to say, for you to just think about it. Do you get my point? Or like in series. If they are in series, the work you do from here to here is different from the work you do from here to here. Abi? So now, current flows. Let's call it I total. Now, when this current gets to this junction, what do you think will happen? It divides. Let's call that I1. And the one coming through here, let's call it I2. So, meaning that I total is no longer the same as I1 and I2 now. Abi, they are found divisions. So at the end of the day, I can say V total is equal to I total multiplied by R total. Do you agree to that? V1 also. V1 is equal to I1 Abi R1. And V2 is equal to I2 R2. Is that clear? So now, let's go on. With this now, I can check how the current flows. But the potential across everything is the same. V total is equal to V1, which is also equal to V2, because they are in parallel. The potentials are the same. Meaning that I can now say V total, or let me say from here, I total is equal to I1 plus I2. Look at that, do you agree? Do you agree to that? I total is equal to I1 plus I2. So now, from this point, I can make I total subject of the formula. So I can say I total is equal to V total over R total. Abi? Here too I can say I1 is equal to V1 over R1. And here I can say I2 is equal to V2 over R2. So bring all of these guys here. So I can say I total is V total over R total, right? Then I1 is V1 over V2 over R1 plus V2. All of these V's are the same. Let me bring this V out. So I can say V total into 1 over R total is equal to V1 into 1 over R1 plus, let me just say V. Check it. 1 over R2. Because the V's are the same. So if I say V times this times V over R, V times this V over R, check it. So now this V and this V are the same. So I can say 1 over R total is equal to 1 over R1 plus 1 over R2. If you see where it's not writing here, it's not sweat on the board. So, actually, teachers we are not competing with Jesus now. But after Jesus, teachers are the ones you should also really adore. You should appreciate, and that's the funniest thing. Teachers are the ones that you ridicule the most. Although Jesus also was for free, but teachers were not usually for free. Jesus shed blood, if they are shedding sweat. Problem here, my shed sweat. That's why as my sweat is touching the board, not to permit, that's to show you how much the sweat is. Your reward is in heaven. Reward not reward, you're not while you're not over the Even the Bible did not even say, man shall them twisted. The Bible said, behold, I come quickly. Come to where? Is it come to heaven? Behold, I come quickly. And what is with me? You will not carry it. Behold, I come quickly, and my reward is with me to give to everybody according to. So the Bible that says that behold, I come quickly. Where is Jesus coming? Son, where? I'm just saying, but we have reward both here on earth and in heaven. So the work you do for God, you will receive the reward both here on earth and in heaven. But the work you do for humans, you store treasures in heaven. Let's go on, please. So what are the points we note here? One. Buddha tell yourself, Buddha, or 4 people. They say you should line up for candidates of heaven. Or the class require Lauren. Wàhálà ìkó tó kan wúrà. Mo dẹ̀ jẹ́ ìwé ló lè fa kíní wọlé. Ẹ kúrò lọ́nà. Wúrà ṣe máa sáré yẹn. Ó máa fa everybody. But don't worry. I can't just go to heaven living here. You can hold on to my leg. When I'm flying, you go with me. I cannot give anybody water. I don't come and even if it's a drop of water, I'll do it. But when we are going, it's about to love by, you have the right to hold my leg. But to buy who to my guide and so cannot follow me. Emmanuel cannot follow me. I said, I cannot hold my legs. Emmanuel madam, Fami madam. But you don't worry. I'm the one. We'll go together. There are some of you that are tiny that I just don't do like this. Example. Oh, the business search, no. There are some people who are not bad at one. No matter our father. God will just have to come back from there. Brights, I'm not talking to you, I'm not greeting you. Brights, I'm greeting you. Are you bright or Tony? Ọ̀la akọ̀rọ̀ àgbóúnjẹ sílẹ̀ ṣáà jẹ́ lọ àbọ̀. Emmanuel Awatede. And bright is not getting that big. Before you know it now. Emmanuel, bright, come and be Jimmy. Let me train you. But just be careful, some boys. One boy was saying that did you wear bra? Who them go? And then was it on which day was the person talking? Samuel Nyabi. Bright, Joma Francis Samuel. So 1 over R total is equal to 1 over R1 plus 1 over R2. Now, the point you need to know here is number 1. So listen, when they are connected in parallel, the currents flowing through the circuits, will it be the same or different? Different. So right. The currents across R1 and R2 differ. The currents across R1 and R2 differ. Number 2. The potential, will it be the same or differ? The potential difference across R1 and R2 is the same. Are you there? Number 3. I said the potential difference across R1 and R2 is the same. The lecture one. I'm not going to share. I'm not schedule back over. What is over soon? Immediately after JAMB like this, all of us go and sleep. After JAMB, we sleep. Una padà sáwọn kò ní àmọ̀bí ẹ̀. So after JAMB, we sleep for like 1 or 2 weeks before they release the results. It's that time that the result that is always worse. Even the person that is sure that he or she will pass. Even when I wanted to check my JAMB result, my heart was like, but tí mo gbé jẹ́kù tó dẹ̀ náà kó máa fi mí ṣe ẹ̀ pé olúwa tàbí lọ́wọ́ jẹ́kù rí gbogbo àwọn tó máa fi mí ṣe ẹ̀yẹ tó bá rí rìsọ́ọ̀tì ìgbà ẹni bí màá níwájú wọn kù àṣẹ ọ̀mọ̀wé kò dára. So as possible you will rest, you will eat, you will play games. You will see movie. You can chat with your friends. Ask them for their results. But don't forget, after results, you will lose friendships. You will lose some friends. Because some people will be too shy to tell you their results. They will be shy. And some people will just keep it to themselves. That's why you have to work hard now. But it does not mean that if you fail, that you are a failure. Does not mean. All of you have different types of preparation, you have different challenges that you are all facing. So it is not for you to feel down or anything. Someone might have 300 plus beside you and you don't go up to that person. Don't compare yourself. Just thank God for what you had. Those are the ones that work hard though. But if I know you were not serious, no dey sọ̀rọ̀ sí ẹ o. At the end of my encourage ẹ náà ni. It does not matter. I will still encourage you, however it is. But don't because of anybody's results now be jealous or lose friendship or life goes beyond all these moments. Life goes beyond all these moments. The thing is just do your best now. Work so hard. Work so hard now. All of you will still meet. Whether you like it or not, you will still meet in the future. Àtẹni tó kọ́kọ́ lọ, àtẹni tó lọ late, àtẹni tó the most important thing is everybody's happy ending. Hello. It's okay. I told you people, I have a lecturer that spent 16 years in UAE. I think he was in medicine before. I didn't really get that part very well. But when he was telling me, it's okay. He was sent out of campus when he was maybe in medicine. And he wrote JAMB over and over again. He didn't even go home. He was just on campus here. And he wrote JAMB over and over. And he was not now passing the JAMB. But he was still remaining in UAE. If it's you right now, they might have known at home if the parents used to follow it. But in UAE, only people you want them to know, they know. Your friends might not even know. and you be attending classes together, and they have sent you out of campus, where you does not release all those book of life thing. So, and the person was there for years. Then after like 12, 10, 11, 15 years, and now pass JAMB again. What's it called? And when he passed JAMB, but now, he now went to microbiology and he graduated with 2-1. Funniest thing is now, he was mature enough, he now became a lecturer. With those people that lectured him, they are now at the same level. So most of his lecturers there, because they had some issues, so when we were on campus, they used to fight. He already felt like he's now a lecturer, he's not at a position of, some people don't have that humility. To the extent that, as I am now, there are so many students that have thought that they went through me, they went through primary. It's not me, it's not pride, it's not anything. We are the same. If you pass through me or anything, we are all the same. It does not matter. I mean, I've never put age or gap or anything because we are all growing together. So, there are some people that when they pass through you, at a level in life, they will no longer acknowledge you. And because they are even richer than you, they will throw it at your face. And that's the same thing that I think happened. So all through these lessons on campus, is him and every other lecturers are always fighting. Because those lecturers felt like you were our student. When I was lecturing, you were still a student. Now you are a lecturer. You are a doctor now. I'm a doctor. But being doctor, if you have done your PhD, you are not a doctor. But now, being a doctor, it still does not mean that you should not know your mates to some extent. We might sit on the same table. The last conference they invited me for now, and when I got there, I saw some of this dean of faculty of science who was on the table. I saw the same doctor then, he's not a professor, that told me to go and write JAMB again during my own JAMB. I was sitting on the table with him. But immediately I got there, I saw all of them on the high table. First thing I first went to meet the dean, the Dobale, and he shook my hand, and I greeted the prof too. I greeted everybody. Then I sat, we were all sitting together on the same table. And the award they gave them, they gave me the award. So, funniest thing is that it's my own students in 400 level that is now the president of the faculty of science that invited me to come and speak to all those OAU students. And they awarded me too. But I did not get there and I say, it's not to I take it. I still went around there, I double it, and I went to sit. And after some of them we talked again, Even I have a doctor that was in this thing there. I was telling her, we sat together. The picture is there. So we sat and she was telling me about many of you, when you leave, you don't come back, this and that. I said a lot of people don't come back to this. And she said yes. And she said, let's exchange number, this and that. As simple as it is, ibi tágbà bá wà lọ́mọdé máa bá. But ọmọdé náà gbọ́dọ̀ ní ọpọlọ láti mọ̀ pé àgbàlagbà máa jẹ́. That honor has to be there. So they always have that issue. So the point I'm making is that after these 16 years, this person became a professor. He's not a professor. When I was there, was a doctor. He's not a professor. And his wife is a medical doctor. They have 3 boys, 3 children that are doing well in life now. After 16 years of struggle and all of those things, they have their own house, they have cars. If he travels abroad to take vacations every time he likes. Yes. Now imagine that when they sent him out of OAU that time, and I said, And funniest thing is that he told us he said he used to teach too. Then he would go to Lagos, he would go and teach. And then he used to sell all these around there, bushmeat. When they kill the bushmeat, he will now package it in a nylon. He will put microbiology details on it and say that this has been microbiologically tested, the NAFDAC number, this and this, and he will take it to all those house estates and be selling it to them. So, only because he told us some of those challenges, we might not know. So don't be bothered about what anybody is saying about you. Please. The thing is, have a dream. It's not easy to even start. It's not easy. Some of you in this class now, most of these things as we are saying it, but you are just looking. Yes, it's called the humble beginning. It's your humble beginning. Don't forget your humble beginning. It's another problem with many of you. Never see more control. You are the one that made yourself. Don't forget. Remember that day that someone sitting beside you. I remember Akisoto, my friend. We went to write GC in biology. Soto was, I was just like, she don't call textbook me. Immediately they gave us questions, we just started writing everything, paper, and I was sitting beside him. He was my secondary school mate. But then, I'm not sure I saw that result, no? But in parallel, he got pharmacy. Then when I started reading, he was my secondary school mate. When I started reading him, he would be reading his pharmacognosy and all these textbooks then. Now I'll carry my landlord. I'll go to him, sit down beside him. They'll call me. And I remember pH. He was teaching me pH. He gave me all the formulas to calculate pH. Down, I did not remember. I don't know anything. But I was trying. And at the end of the day now, he's doing well in the field of pharmacy. I'm doing well in my own field. When we first started primers, he recommended several students to come to primers that are doing well now. So, life continues. I should not, because of that, because he gained admission before me, or he got pharmacy before me. Even me later, I later got microbiology, not even pharmacy. It is medicine I'm doing now. At late hour, I'm still doing medicine. I got micro, he finished from pharmacy. But everybody's life continues. So don't picture people's life based on your own life. Funniest thing is anything what we are there to look at the challenges here. Our challenges don't buffer. One more. It might not just be academics. There are some other challenges everybody is facing. So when you face here, don't compare yourself. I hope you can hear me. You are the one to face your own challenges. Don't compare yourself. When you get out there, you will see the difference. The difference is not in this class. I used to even tell you that your competitors are not in this class. They are outside there. All this, Ele to work there, who scored 300, Joelo, Ele scored 290, Ele shaking. Your competitors are out there. If you score 320 here, there will be someone out there that scored 350. So you scoring 320 here, and your friend scored 270, 220, and you are feeling like your 320 might not go anywhere. As much as you look outside, you see a lot of people that now score higher than what you. So focus on yourself. Why are you focusing on competing with your friends? God will help all of you. So please don't be scared. So last one, I said the potential difference must be what? The same, Abi. So last one, the combined resistance or the effective resistance. The combined or effective resistance. 1151. The combined or effective resistance must be lower than the individual resistance. Must be lower. The combined or effective resistance must be lower than the individual resistance. So what we are saying is this. Let me just quickly give you a question on that before you have your break, so we can come and complete some chemistry. Now, let's say this is R1, this is R2. They are both connected in parallel to a battery. This is 2 ohms. This is 4 ohms. Now, they now say calculate their combined resistance. Number one is that as current is coming, when the current gets here, it will divide. Abi? So number one, current will be different, currents differ, abi? But because they are in parallel, so you can still say that the work done across them is the same. So potential is same. But the combined resistance, or what we call effective resistance, will be lower than R1 or R2. That's the third statement. So let's confirm that. For resistor in parallel, this is the formula B. So that's going to be 1 over R effective is equal to 1 over R1 AB plus 1 over R2, and that's going to be 1 over 2 plus 1 over 4. AB, if you find your SCM, that's 4. 2 in 4, 2 times 1, plus 4 in 4, 1 times 1. And that's going to be what? 3 over 4. So another mistake you should not do is this one. Some people will not go and do 3 divided by 4. Once I pick answer, they will not cross multiply. People do that error a lot. They just quickly pick 0.75. Whereas you have to cross multiply. Sure you get. So your answer is 4 over 3, Abby. So we are now going to have 1 over R effective is going to be 3 over 4. Be careful, then you cross multiply. R effective is going to be 4 divided by 3. 4 over 3 is what? 1.33 ohms. So not 0.75, and 0.75 will be in the option. Question can be simple, but basic errors can make one miss it. It happens to me a lot of times too. Even in this current one that we just finished. Instead of 1 over 2f, instead of 2f, I chose 1 over 2f and I solved it. So please, all these are common errors. So now you can see the answer we got here, 1.33. This 1.33 is lower than 2, Abi. That's what these statements mean. R effective is always lower than R1 or R2. So it's lower than 2 and it's lower than 4. So note that statement. So now, from what we have done so far, another thing you need to know is that when they are connected in parallel, you can, and there are just 2 of them, instead of this, you can just use products over sum. Abi? So you can just say that R effective is equal to products over sum. And the product is, that would be multiplied, that's 4 times 2 over 4 plus 2. Abi? 4 times 2 be 8 over 6. She get 2 here 4, 2 here 3. And that's why we have 4 over 3. Do you get that? So that's always faster than using that other one. But when you do product over sum, don't cross multiply again, no? Do you understand? So it's just a shortcut to do for when you have 2 of them. So we can quickly go for a break now. So by 12:30, we'll come back to complete our chemistry where we started by 12:30. So the question that was asked, sir, what if they give us the currents and they ask us to look for, I think I've answered this one. There was one that, what if they give us the currents, and they ask us to look for internal resistance, or is it not possible for them to answer? They can ask you anything. They give you current, they give you voltage, they say look for internal resistance, it's possible. They can give you current and give internal resistance, say look for voltage. Anything can be asked. There's no district in the direction. Yes. Sorry. Quickly. UI resumes today, the 100 level, and which we have resumed. I'm not supposed to be around today, but if we die, we die. So, But the most important point is that, please listen. I told you that you should please help us to contribute 1k for some of our students that taught you and are going to school, so that we use that to sort part of their school fees or the things they need on campus for themselves. It's just us giving out for them. So they have sacrificed their time, they have sacrificed their energy to help you to help them. So don't be ìjọba ọ̀run lè rí onígbàgbọ́. Yes, ìwọ fìyẹn sílẹ̀ fọlọ́ pẹ̀lú àṣẹ́tù rẹ̀, ìwọ ṣẹ́tù títí ẹ náà. Kọ́ máa sọ fún wọn náà pé ìjọba ọ̀run lè rí ẹwà lọ́la. Is that taking? Please, how many of you have paid your own? Blessed, if you have paid your own. So please, we are begging you, just give it. Sacrifice. It's called sacrifice. You don't know, maybe it's a sacrifice for your exam. You don't know. Wawari question, join a question, Mawari question. You don't know how God is doing it. Sacrifice. If we talk tomorrow, we talk to me, sacrifice. We are begging you. So please, God will bless all of you. I'm not attaching it to your success. But we all know that when we give, there's always a way God will pay us. So that's what I'm saying. So please, God will bless all of you.